Verbal or chat's acceptable, either one. What do you think?
Well, what I understand was that we were virtualizing the running environment for the app, but we were utilizing the underlying OS. So we were not virtualizing the OS inside of our container.
You were not virtualizing the operating system. That's good.
Correct.
Okay, perfect. Okay, so then that begs the question. So if I have a bunch of, let's say, virtual machines here, right? Actually, we'll just make this easy. That way we get same shape and size, right? If I have a bunch of virtual machines here and I'm decided that I want to, containerize something, right? We know that when we containerized, like whatever it is, we haven't pinpointed it yet. Virtual machines, we know, are basically sitting on top of a piece of hardware and we're virtualizing the operating system. You just pointed out that containerization does not virtualize the operating system, but it does virtualize the environment. But we want to get a little bit more specific. Containers are going to be virtualizing what exactly? When you say environment, what are we talking about? Are we talking about the memory space? Are we talking about the networking? Are we talking about the file system? Are we talking about the processes? What are we talking about? Anyone, by the way.
Yeah, my understanding was all the environment settings, like the variables, as well as like any dependent apps or services that are required.
Okay, so variables, by the way, are defined in the environment, usually through environment variables. They can also be defined through files, right? But what is the core thing we stick inside of a container that must absolutely be there in order for it to actually do anything? What do we stick inside of a container?
The application.
That's right, we got to stick an app, right? Now that app is usually defined as some kind of artifact, right? So if we say, look, this is the core of everything, is that we have put basically an app here. There's an app. Now, is that app Java? Is it Python? Is it Erlang? We don't care. Is it a .NET binary? We don't care. Now, we will care when we actually go to execute it, because just to be clear, containerization does not solve the problem of you cannot run a Windows binary on top of a Linux operating system. Is everyone following me? We still are constrained by processor architecture, and we're still constrained by operating system architecture. But if I've got an app and I decide, you know what, I actually do want to stick this in a container. I'm really excited to do that. And I want to just go ahead and make sure that this app lives inside of a containerization space. And let's just send that to the back. Actually, let's move this out of the way, because that's going to be in, you guys can't see that, but that's okay. So here now we've got this containerized. Now, let me ask you this. What's the most popular flavor of containerization in the entire world? If I say containers, what's the first word that most people think of?
Docker.
Docker.
That's right. In Docker is to containers what Kleenex is to tissues. Everyone following me? Docker is to containers what Kleenex is to tissues, or what, Coca-Cola is to like soda, right? It's like, it's just a brand. It's just a brand of containerization. Now, don't get me wrong, we're really thankful to Docker, because Docker gave containerization to the world. And if they hadn't done that, along with Core OS, which got bought by Red Hat later, we would have been in big trouble, honestly, because it wouldn't have been standardized and not everybody could use it the way we use it now. So we're thankful to Docker. Unfortunately, they gave it away, probably from a business model that probably wasn't the best thing for them, since they're struggling to figure out how to make money, even though they keep getting funded. It's really strange. But regardless, that's all side note. So app is in red, orange is our containerization, right? And let's say that like we've actually gone through the process and this is a Docker container, right? Just to make it easy. Because we're just going to stick with our most popular flavor. Now, what's the problem if, let's say I'm like, you know what, I'm just going to use Docker. I'm going to take this little, Docker image and, I'm going to take it and I'm going to run it on like a bunch of machines, right? So let's say I'm really hot and heavy on this whole thing. And I like, I really love Docker containers. I'm going to run this out in production. What's the problem with doing this? What's the problem with that?
You still only have a set amount of resources on the infrastructure.
That's true. But I mean, I could copy this out, could I not?
You can.
And then I could copy this out, right? Could I not? I mean, I could actually run this on multiple machines, right? But let me ask you this. Do these machines talk to each other?
Unnecessarily.
That's right. In other words, what do we need to do to systems? Like if we were running a database, for example, and we wanted to run a scalable database that like where all the databases talk to each other, like an Elasticsearch setup. Notice I didn't use the word that it usually follows Elasticsearch, right? What do we call that when we take a group of systems and we make them talk to each other for a common purpose and they're linked together? They maintain state together. What do we call that?
Cluster.
That's what we call it, a cluster, right? So if we take all this and we said, you know what? This is all nice and cool, right? Oops, I didn't delete. That's weird. But what I really want is, I want the ability to click on something and delete it. Oh, I love how this works sometimes. And what I really want is I want to be able to take these systems here, and I want to be able to scale them across many different nodes. Now, usually when we do that, we're going to basically set up what's called a what cluster. What's the #1 containerization software for clustering in the world today?
Kubernetes.
Wait, no one's going to challenge that and say Nomad or OpenVC or whatever the other, I don't even know what the other ones are now. It's been so long. It's Kubernetes, right? So just to say this, let me ask you this. This Kubernetes software, does this run on top of virtual machines or on top of physical hardware, or does it run in some other capacity?
It could run on a virtual machine. Or on
Well,
or OS running on a physical hardware as well.
That's right. That's exactly right. So to make sure that we're all in the same understanding, Kubernetes is nothing more than a container orchestration software that sits on top of an operating system. It doesn't care whether it's physical hardware or virtual hardware. To be frank, most of us are running it on virtual hardware, but it could run on physical, as Kenneth pointed out. No problems, right? I got Raspberry Pis all over my house that run Kubernetes, right? That's physical hardware. Although someone did suggest that I try virtualization there. I was like, I don't even know those guys have enough resources, but moving on. Okay. Now, in order for us to deploy a container in Kubernetes, what is the base unit of deployment in Kubernetes? What do I have to do in order to get a container to run on Kubernetes? How does Kubernetes handle that? What does it do to it?
It needs a pod, right?
Well, and that's really just another abstraction layer, right?
Right.
Which, by the way, you are right. Isn't it interesting how we just add abstraction layer after abstraction layer? Is anyone else getting kind of weirded out by this? Hey, you know, this is the age of abstraction.
Is it the Docker file that defines the contents?
Ah, that's a great question, Robert. So if you write an app, let's say you write Java, you write an app in Java and you want to build that app, you're probably going to write either a Gradle or a Maven like file. You're going to do a POM file or something like that to compile that artifact into something that's deployable, right? So that file is associated with an app. The Docker file is associated with Docker builds. So when you want to take that, let's say, artifact, which by the way, you could call the artifacts build tools if you wanted to, and you want to build that artifact, you want to put it into a container, that's where the Docker file comes in, right? But when you want to build a pod, someone tell me what file in Kubernetes do we have to create? And it could be called anything, but what do we have to create in order to define a pod in Kubernetes?
You need a kubelet. Is that what you're looking for? I'm not sure.
No, not quite. You're a little ahead on me on architecture there.
Okay.
I thought there was another like deployment file that defined what was being deployed and the networking, things like that.
Good. Okay. Excellent. Because let me just say, this is all like fun and games around abstraction, right? And by the way, this is all relevant for Rancher. So don't worry, we're not wasting our time. This is all going to be super relevant for Rancher because if I don't know if any of you have seen the movie Inception. I hope you have, because this is what we're doing actually right now. Okay. So we've got an app. It's sitting inside of a container. It's inside of a pod, right? And by the way, we could have multiple pods, right? So I'm not going to draw the rest of it, but let's say we got multiple pods running across our systems, right? So these pods could exist across these hosts that are down here, but I'll get to that in a second. But then I asked you a question. I said, what do we need in order to define a pod? And there's a couple of different ways to do this because a pod is where containers get deployed. Now, by the way, can I stick more than one container inside of a pod?
Yes.
Yes, Terrence, I can. Let me ask you a question. should you stick more than one application container inside of a pod?
Probably not.
And I like how you said that because you didn't say no. You said probably not. By the way, if you ever want to know whether or not you should stick more than one pod inside of more than one like container inside of a pod, ask yourself this question. Do you want them to scale together? If the answer is yes, then you can actually stick that container inside the same pod. If the answer is no, and you don't want them to scale together, then the answer is that you should stick it in its own pod. As a general rule of thumb, most applications do not scale with other applications. Let me clarify that for those who are kind of in the audience who are kind of wondering, right? If I have a WordPress installation and I've got 7 Nginx servers in front of it, and I've got 1 WordPress installation in the back, and the database is overloaded. First of all, if I do a one-to-one relationship where I stick a Nginx system and a database inside the pod, and I have 7 Nginx web servers, I automatically have 7 WordPress databases, do I not? Do you see now why you wouldn't stick, for example, the database layer in with the front end web layer when you have an application that requires 2 containers to run? You wouldn't do that, right? Because every time you scaled Nginx, you'd have to scale the WordPress instance. You're not going to do that, especially not with WordPress, right? You might do that with Elasticsearch, but even then it's going to be catchy. So just to be clear is that the only time you stick more than one application inside of a pod in Kubernetes is if that application is going to scale step by step with the other application that is inside the pod. 99% of use cases, you are not going to stick more than one application container inside of a pod. So most of the time, you're not going to see this. You're going to see just this. There's going to be one app in there, in this Docker container, and that's it. And so as that pod scales, it's going to scale 1 container. It's going to scale 1 app. So if this was our Nginx example, you would see 1 Nginx app inside of a container, inside of a pod. That pod would scale however many Nginx web servers you needed, and you would not scale that. You would scale them independently of a separate pod of WordPress MySQL instances that would then scale independently. So you might have 20 Nginx instances. You might have 1 primary WordPress instance, MySQL, 2 reader instances. So you might have 3, right? Just as an example. Did that not make sense to anybody? Because we can go over that again.
It makes sense, but do we determine that, or does Kubernetes determine where it puts the pods?
Well,
or containers?
I know I get beaten up by my enterprise architect friends for saying this. Everybody's an architect. Everybody makes design decisions, right? So whether they're at a systems level or a solutions level or an enterprise level, everybody makes design decisions. So the answer is that you might not be the primary decider, but you might be the guy that goes, hey, just to check, did you stick that WordPress MySQL instance in with Nginx? Do we want those to scale together? You might be the person who raises that question, right?
Oh, I think maybe you misunderstood my question. I thought that was automatically handled for us by Kubernetes. Kubernetes decided which application containers ran inside the pods, and it was kind of like out of our control. That's why
No.
it was not true.
No, you have
Okay.
full control over that. Yeah, you get
Okay,
to
good.
decide how everything is podded together, right?
Okay.
Yeah.
Cool.
So, and by the way, the base unit, the base like file that you would use to declare a pod is actually just a pod YAML declaration. Just to digress for a second, let's go take a look at that. By the way, if you haven't seen the Kubernetes documentation, you should get familiar with it. It's really comfortable. All right, so pods, right, are the basic smallest deployable unit of computing in Kubernetes. They always have at least 1 application container in them. You might say, Michael, why do you keep saying 1 application container? Because they could have security containers and operations containers and logging containers. They could have other non-application containers in that pod that could do things like intercept traffic for scanning. It could, write out all your application logs. It could, scan the local file system for flaws and vulnerabilities. So just know that inside this image that we're creating here, there actually could be other Docker images, but they're not related to the application in the sense of offering a service to customers. They're related to the operationalization of your business. So Kroger probably has security requirements and operations requirements and logging requirements. And so you might have those running inside the same pod space, to support, whatever, compliances you need. So hopefully that's not your deal. Hopefully most of you are developers. Is that fairly accurate? That might be a good question. How many of you are software developers? Give me a yes on the chat if you're a software developer. Oh, how many of you are architects? How many of you are in operations? DevOps, SRE, whatever. Okay. I see a couple people in cyber. Sorry, security. Good. Okay. What am I missing? Because there's 15 of you. Do me a favor and post your role really quick so I know who I'm talking to. I should have asked it ahead of time, but I'm probably a little foggy, as you can probably hear. Oh, good. All right, so for those of you in security, make sure I hook you up with the NSA's guide on security hardening if I haven't already, but before we leave, I'll post the link, but you could probably find it on your own, but I'll make sure that you guys have that if you're dealing with security inside of Kubernetes. Security is one of the harder things inside of Kubernetes. All right, good. I got an SE manager, good. A couple of devs, an architect, Terrence, good. Network security, okay. All right, who am I missing? Is that everybody? Is everybody either a developer or an architect or in security? Or a manager? Huh, okay. Good enough. All right. All right, so please, double down and ask me questions if I making assumptions here. Okay, so YAML files are basically what we use to define everything inside Kubernetes. So if you haven't heard this before, and hopefully you heard it from Kevin Clements, right? The guy who taught this last week. Was it Kevin? I think it was Kevin. Anyway, hopefully you heard him say that everything inside Kubernetes is an API. Every single construct is called an object. Pods are nothing more than objects that contain containers. Isn't that funny to say? Pods are nothing more than objects that contain containers. Containers are nothing more than objects that contain apps. So everything you want to define inside Kubernetes, if you are doing infrastructure as code, right? And so David in particular probably knows what I'm talking about, but most of you probably have an idea, is that you want to make sure that you actually write YAML files for all your stuff. What does that mean? Right? Those YAML files that you messed with last week, right? This is how you define objects inside of Kubernetes. Which of the fields here, by the way, determines what type of object you are defining in this YAML file? Someone tell me.
Kind.
Good. That's really the most important one. By the way, no one has these specs memorized. Even I don't. I will output a command in order to dump the specification out, or I will go look at the documentation. But other than that, just to be clear, no one has these specs memorized end to end, especially these are simple ones. Most of them are super complex, right? So just to be clear, you're not expected to be able to rat this off. I've even taken the CKA exam, and I got to tell you, even then they don't expect you to do it. You have access to the documentation while you take the exam, just so we're clear. So don't get intimidated by this. The only thing you need to be super aware of, and please talk to your developer friends if you're not familiar with this, is be aware of the two space shuffle with YAML. Does everybody know what I'm talking about? So hopefully you ran into this last week. You ran into some pain with YAML where you're like, I forgot to put 2 spaces in and my YAML wouldn't process. Does anyone not know what I'm talking about? Because, there's 2 spaces between spec and containers. There's 2 spaces between that dash in front of name and image. So I'm hoping you all ran into that. So that's the one thing you just need to remember about YAML is that 2 space shuffle. Otherwise it gets really ugly. Now notice here, they're defining a pod and then they're applying the pod YAML directly to the Kubernetes installation. And what it does is it creates this object. What object is it creating? It's creating a single container that's using the Nginx image at 1.14.2 tagged, right? And it's going to run it, expose it on port 80. Well, not really, but kind of. Just follow me with that for a second. But this is how you define all objects inside of Kubernetes. So why are we kind of going around this whole thing? Here's why. Earlier, and I don't remember who said this, someone made a comment and said, you know what, Michael, you can define a pod by using what's called a deployment. Well, let's be clear. Kubernetes loves abstraction. So let's change this to green just to make it garish, right? So this whole thing can actually be stuck inside a deployment, right? Now, here's the catchy thing about deployments. Let's make this super big. Is a deployment can contain multiple pods, right? So remember the name of it when I actually define multiple pods? What do we call that? What are those multiple copies called?
Replicas?
Replicas, exactly. So if we go inside the Kubernetes dashboard and we look at the setup, there'll be a section in there. It says, hey, I've got 3 replicas. If I have 3 replicas, that means I've got 3 copies of that pod. These are all the same app, by the way, in a deployment. So for example, this deployment could be my Nginx deployment. I could have another deployment that has my WordPress installation. Now, this particular object in Kubernetes is known as a workload type. Just as a review, someone tell me the other workload types that are available inside Kubernetes. What's another one? What do I use if I want to run a stateful system?
Like persistent volume?
Persistent
Client?
volumes can be attached to any deployment type, any workload type. I know that's weird. I'll talk about that in a second. But what's the name of the workload type that you would use to run something you wanted to be persistent?
A job,
Jobs are used for batch jobs.
right? But is that a workload type?
It is a workload type. That's
Mhm.
perfect. Just added it to the list. What's
Mhm.
another workload type?
Service?
Services are load balancers. So think of services as load balancers.
Okay.
So deployments, batch jobs. Did you guys talk about cron jobs?
A little bit, yep.
Okay, good. What other types are there? What if I want to run a database? What do we say that's the best workload type to use for databases?
A daemon.
Nope, daemon sets are actually used when you want to run a workload on every single node, virtual or physical node in your system. So for example, if I have a logging agent that I want to run on every single node in the Kubernetes cluster, I would actually run it as a daemon set. That means every time Kubernetes added a node or removed a node, it would run it as a daemon set. That ensures, by the way, that it runs once on every single node inside the cluster. Stateful sets, which by the way, do not grant it any special storage privileges. Stateful sets are used for like databases and other things that you want to consistently find by name. Why? Because with deployments, batch jobs, cron jobs, and even daemon sets, the names are going to randomly change on you. So if it says WordPress-F6509-F666699, it's going to change that last thing every time that pod restarts. With stateful sets, if I call it WordPress, you know what it calls it? It says WordPress-0. Guess what happens every time WordPress restarts if it's a stateful set? It's WordPress-0. It stays WordPress-0. If I add a second like pod to the stateful set, it becomes WordPress-1. If I add a third, it becomes WordPress-2. The bottom line there is that stateful sets make sure the name stays consistent. You might say, Michael, why do I care if the name stays consistent? If you are running a bunch of Nginx servers that are constantly looking for their WordPress database, you don't want the DNS name to change every 5 seconds because Kubernetes decided to restart the pod. So just be aware that stateful sets keep the name consistent for persistent data stores like WordPress or like MySQL or Elasticsearch or Mongo or whatever you're using. Okay. So those are the 5 workload types. Note, by the way, that every one of these workload types can start a pod. Remember, the pod is the basic unit of deployment inside Kubernetes. Okay. So to put this all together, apps live inside containers. Containers can be Docker containers. They could be Podman containers. They could be Builder. We don't care. But let's say they're Docker containers. Docker containers are built by Docker files. those apps inside those Docker containers are then deployed into pods inside Kubernetes. It could be one pod, it could be 5,000 pods, frankly, right? Meaning you could scale one app 5,000 times or more if you want to. Just depends on your resource capacity and availability. Just note that the number of pods you have is determined by the number of replicas that you define in your workload definition. What did I say was required from a file perspective for you to define an object inside Kubernetes? What do you need to do? What do you need to type up or create to import into Kubernetes if you want to create any object?
A YAML file?
That's it. I know it sounded like a trick question, didn't it, Kenneth? It was like, hold on, give me a YAML file. Give me simple. Michael must be messing with us, right? Michael has a cold, so Michael's not messing with you. Things are going to be very simple today with a topic that's already complex, right? Okay. So that's the main thing I want you to walk away with this from, is that regardless of whether you're a developer or security person, you're going to deal with these 4 abstraction layers constantly, because, by the way, all of these pods are going to live on side of a node, right? They're going to live on side of a virtual machine. Does anyone know the maximum number out of the gate number of pods that you can run on a virtual machine inside of Kubernetes? Does anyone know? Kevin may not have talked about this.
Wasn't it 5,000?
Aha, David, that's a great number. 5,000 is the maximum number of nodes, virtual machines or physical nodes that you can run inside of a single Kubernetes cluster. So that's a great number to remember. I actually did a proof of concept for the NFL earlier this year, and we ran like 4,000, like 4,500 machines. It was ridiculous. It was the largest Kubernetes installation I've ever done in my entire life. Wow. So it was ridiculous. Never do that again, by the way. It's not practical. Remember, it was a proof of concept, so we found out that it was a bad idea. Just separated them into different clusters. It's a whole other discussion. All right, so 5,000 is a good number to know, but on a single virtual machine, it's hard-coded, and it can be changed, so you can change it inside Kubernetes if you want to, that you can only run 100 pods on top of a single virtual machine. So for example, if you have 5,000 nodes, let's say you go to the max that Kubernetes can handle, a 5,000 node cluster, and you run 100 per, right? You're looking at what? 500,000? 5 million?
5 million.
My math is way off. You're looking at 5 million, right? You're looking at 5 million pods that you can run.
500,000.
Yeah, again, I'm a little delirious, so I'm going to trust you on that. So the point being is that 100 pods are going to run on a single node. And the reason for that, by the way, is mainly around networking. Networking and security are harder inside Kubernetes because networking gets so convoluted. Now, for you cyber guys, I'm just going to apologize ahead of time. You're going to have to learn how this works. But for the rest of you, thank God you're going to dodge that bullet. You're just going to have to learn how the rest of Kubernetes works. So just be mindful that 100 pods per node, if you use something like OpenShift or another like managed Kubernetes provider, sometimes they'll allow you to run like 200 pods per node, but just know they've customized it. Kubernetes out of the box will only allow 5,000 nodes per cluster and 100 pods per node out of that 5,000. Okay. All right. So this is a lot about what happens on the worker side of things, right? Because everything in Kubernetes is an API. But let's ask you this question. If we were to take all this and just set this aside for a second. If Michael could scope this properly, let's move this off. Now, in order for you to be able to talk to the worker nodes, what do you need in your architecture in order for you to be able to run like kubectl or other API calls into the cluster? What do you need for that?
Network.
Well, you definitely need networking, but from a Kubernetes architecture standpoint, what do you need to make this work?
So this is where you get into that, what was it called? Kubelet or something? Orchestrator?
Well, what do we call the things that actually control the cluster? What do we call that role? Because they're not working.
Master?
Control
Right, we
plane.
call them masters or the control plane. That language is falling a little bit out of favor, so people are starting to call them primaries now, right? So let's say we got primaries here, and I'll make those a different color so we can actually see those a little differently. So we got primaries here. Now, Kubernetes has a number of components that sit on these primaries. Someone tell me, what are one of the components that sits on this primary that you would probably see if you could like peel inside the primary? What's one of the pieces we might see here?
API service.
Good, we might see the API service. Excellent. Now, the API service acts as the central hub for all communications inside of Kubernetes, right? Now, so that's a really good one to call out first because, so maybe I can spell correctly. That's really a good one to call out first because that's arguably the most important one. Okay, so we got the API server. Now, where across all three of these primaries, they all have an API server. So let me be clear, everything that I draw on that first box, the other two primaries, the masters, the control plane has as well. By the way, someone referred to the kind of like cluster controllers as the control plane. What do you call the worker nodes? What is that called? As far as planes go.
Nodes.
Nodes, but when we talk about, hey, this is the control plane and the other thing is the what kind of plane?
Data plane.
Chad, did you say data plane?
Yep.
Yep, that's it. Yeah, data plane. So the data plane is where all the work's actually done. The control plane is where all the state is managed and maintained. This is where all the scheduling happens, all the control happens. All right, so we've got an API server. Where is all the state for the cluster stored inside the cluster? What service does that?
etcd, but I don't know what the name of the service is.
Well, it's called etcd. So you did
Oh.
it perfectly.
Okay.
Yeah, you did great.
Hmm.
And you pronounced it properly. That's an old Linux term, by the way, referring to the configuration directory. Etsy. I don't, you know, some of these conventions, they're so weird. Yeah. Anyway, so etcd is the database, by the way. So etcd, by the way, does anybody talk to etcd directly? If I come in and I'm like, you know what, I really want to actually connect. I'm going to take kubectl and I want to talk directly to etcd. Can I do that?
No.
No, because remember, this is a microservices architecture, which means everybody talks to the API server. So if you want to talk to etcd, guess what? The API server is going to do it for you. You don't talk to etcd directly. Now, all you admins out there, you probably will, because, you know, every once in a while you're going to need to administer it directly. But from a Kubernetes standpoint, you're not going to talk to etcd directly. All right, what else am I missing here? What other components should be on this system if it's truly going to be one of the control plane boxes?
Scheduler.
That's right. Now I'm going to ask the obvious question. What does the scheduler do?
Deploys workloads. Or pods.
Yeah, so this is the one, by the way, that goes out and says, hey, if you write a YAML file, let's say you write a deployment, and in that YAML file, you say, look, I'm requesting 1 CPU and 2 gigs of RAM, and I might max out at 2 CPUs and 4 gigs of RAM. So there's my hard limit. I have a soft request and I have a hard limit, right? What will happen is that the scheduler will actually talk to the API server and say, I want you to talk to all the kubelets. I want you to talk to all the kubelets on all the worker nodes, and I want you to tell me who has 2 processors and 4 gigs of RAM free. You follow me? Because that's what I told my deployment that I wanted, right? I want 2 processors and 4 gigs of RAM. So what will happen is that it will then go out and talk to all the boxes, and it'll make a list of all the boxes that have 2 processors and 4 gigs of RAM free. And then what it will do, that's the must-have phase of a scheduler. It'll then come back and say, hey, you know what? Which of these boxes has the least amount of resources consumed? Wouldn't you do that? Like if I got Terrence and Chad, if I got you in a room and I said, hey, you know what, you two, I can give your project a box that has nothing on it and it's got 48 processors and 128 gigs of RAM, or I can give you a box where about half of the processors are already used by other projects and it's got like 3/4 of the RAM used already. We all know what you would choose. Is you'd be like, you know what, my project would probably run better on the box that didn't have anything on it, right? Can we just use that box, right? So just know that the scheduler works in 2 phases. It goes after must-haves, like do you actually have the capacity for what I want? And then it goes after nice to haves, which is that out of the 7 boxes that I found that have the must haves, which one of these has the most free resources, already has my image downloaded, is the fastest? Like it'll actually ask those weird questions that we would all ask, right? Which who's the most performant? So that's what the scheduler does. Now, just to check, do I talk directly to the scheduler or do I go through the API server?
API.
So I'm not going to ask that question again. Just assume, by the way, everything goes through the API server at this point. That's what happens. Okay, what else am I missing? What else should be on here?
Orchestration.
Okay, excuse me. What is that called? What is the orchestration called just for the Kubernetes cluster, not for any cloud provider?
I don't remember.
Ooh, say that again.
I said I don't remember.
Oh, perfect. Well, that's good. I have to say I'm a big fan of I don't know because that's where learning begins, right? It's controller manager. So the controller manager's job is to make sure that all these other components are up and running and that everything's working, right? So its job is to make sure that everything's like kosher just inside the cluster, right? So the controller manager does that. Now, if I am on a cloud provider like Azure, what other type of controller manager do I have in play? Someone tell me.
Cloud.
That's right.
K8 and K8s.
Actually, I don't know that I can say that that's how that works for AKS. Microsoft does not reveal exactly what that happens there on the back end because I don't think you don't get deep level access to the managers. This is if you were running it on like one of their virtual machine sets, right? I'm pretty sure actually there is a cloud controller manager on AKS, EKS, and GKE. I just can't verify it, can't confirm that. All right, so we've got the etcd, we've got the scheduler, we've got the API server, we've got the cloud controller manager and the controller manager. I feel like I'm missing something. Bear with me just one second. See, this is what happens when you do these kind of things. Nope. I feel like there's something missing here. Nope, not the ingress, not the data store, not the namespace. Nope, not the registry because that's external. It's going to come back to me. I feel like I'm missing something here. All right, etcd, API server, scheduler, cloud controller, controller manager. Actually, that might be right. It's going to come back to me. You might be saying, well, Michael, where's auth at? Well, just to say this, just so we're clear, Kubernetes doesn't have a great authorization mechanism. Kubernetes uses certificates with the user inside the subject name and its own certificate authority in order to activate users. If you have to federate Kubernetes with another system to really get good like authentication. And don't get me wrong, you can do attribute based access control and you can do role-based access control. And there's a policy manager and there's a whole language for security in Kubernetes. You can use an admissions control or you could control all kinds of stuff. But you're probably going to end up federating your Kubernetes cluster with another system like Rancher, for example, which is what Rancher does. So the reason we took the time to go over this, by the way, not just how the workers work, but how the like masters, the controllers work, is that Rancher works almost exactly the same way. Rancher was genius in the sense of that Rancher is a layer above Kubernetes. So think about this. We have applications sitting inside of containers. The containers are sitting inside of pods. The pods are sitting inside of workloads. And the workloads are deployed across a bunch of nodes inside of a Kubernetes cluster. Are you following all the layers of abstraction at this point in time? Rancher adds one more layer of meta abstraction because Rancher is a management service for all your Kubernetes clusters. That's all Rancher does. Rancher acts as a meta manager for all of your Kubernetes clusters so that you can actually deploy, manage, log in, authenticate, scale, log, and troubleshoot all of your various Kubernetes clusters from a single Rancher installation. That's what it does. So think about taking all of this, replicating it, because let's say you have 7 Kubernetes clusters and you replicate it 7 times over. that would all get wrapped under one Rancher installation, and you would hit that Rancher server in order to get to all of your Kubernetes clusters. So that's why we did the review. I'm gonna explain the whole Rancher piece a little bit further. Does anyone have any question about anything that we covered here, as far as the worker nodes and the master nodes in relation to Kubernetes? Okay. All these concepts, by the way, you're going to see are going to be applied to Rancher. So it's going to be pretty funny how this works. Oh, there was one other thing I wanted to make sure that you understood. If I want, ooh, that's right. I almost walked away without asking this question. This is going to be super important. If Chad, I'm going to pick on Chad for a second. If Chad was a known troublemaker inside the company, he would write the most cutting edge apps in the world, was known for, like, you know, using bleeding edge technology, which is great because he would drive the company forward. But Chad had a reputation for instability because he was actually using the latest and greatest. And so, you know, it was like, we want to keep an eye on Chad, right? And then we've got, let's say, Ryan, right? And Ryan's like, you know, I write kind of core stable applications for the business. So I'm not necessarily going to be as cutting edge as like Chad is, but I'm going to write, you know, large scale applications for a different purpose, right? Now, of course, I just made this up, so I have no idea if this is actually true. So, and I wanted to make sure that Chad's app was partitioned or separate from Ryan's app, or vice versa, because maybe Ryan has problems. I have no idea. But I wanted to keep their two apps separate. What would I do to the cluster in order to separate these two apps from each other from a security perspective? And I wanted to keep their resources separate and their partitioning. How would I partition this Kubernetes cluster? What is that called when you do that?
A namespace.
That's it. It's just that simple, right? Now, first of all, if Chad or Ryan, if I offended you in any way, or if any of that was true, that was just a guess. But obviously, just to be clear, this is true. You would do this regardless of people's behavior. Like, it didn't have anything to do whether someone is more cutting edge or whether they're more stable. As a general rule of thumb, you're going to run namespaces on your Kubernetes cluster. So Krista is going to be in her team, and her apps are going to be in a different namespace than, say, Robert's versus Kenneth versus anybody else's, right? So just know, and the reason I mention this is that isolation of those security boundaries with namespaces is super important in Kubernetes to maintain security boundaries and partitions. So Rancher will enhance that by doing these things called projects. But before we get to Rancher, I want to make sure you understood what was happening with namespaces inside Kubernetes. Okay, so namespaces are cluster-wide security partitions or boundaries that you can stick inside your cluster. It allows you to basically logically slice your cluster. To be clear, namespaces go across the entire cluster and cannot be bound to certain nodes. So if I create a project A namespace and a project B namespace and a project C namespace, the whole cluster is going to have those like partitions on there, okay? They don't eat resources, so there's no cost to that, but it's just to let you know that they will exist across the entire cluster. Okay. All right. Before we move on to anything else, does anyone have any burning questions? The floor is completely open about anything that you do not understand or any curiosities that you wanted to ask about Kubernetes before we go into Rancher. Okay. Excellent. I hope you found that useful. All right,
One question.
Oh, go ahead.
Can you explain what the cluster IP is versus the load balancer? Because we switched from one to the other, but it's still not just really, we switched from load balancer to cluster IP to save IP addresses, but it's not clear to me why. I was wondering if you could, if it's out of scope, we could cover it later, but I just wondered if you could cover that.
Let's take a minute. We'll take just a minute to cover this. So let me see if I can. Where are you? There you are. you're gonna get a little bonus. Please forgive me because I know that you use Azure. I'm gonna pull out some AWS slides for a second, so just please just bear with me. It's not gonna be about AWS. It's just that sometimes they have some really good slides, so sometimes I like to steal them. All right, so this says communication in Amazon EKS. Forget that I said that. Honestly, this works the same as it does for Azure, and it works the same as it does for Kubernetes in general. Okay, and this is going to explain your thing, Kenneth. Right? So, container. You know, if you have two containers that are inside of a pod, they can just talk to each other. If you have pods who want to talk to pods, they can just talk to each other. Right? So within a Kubernetes cluster, there's no restriction by default to pods talking to pods and containers talking to containers. Don't get me wrong, for all you security people out there, you're probably like, Michael, that sounds like a horrible nightmare. Yes, I get it. You can set up security policies that prevent people from talking to everybody else. Okay, so don't freak out, but you can do that easily. And then there's this thing called ingress to cluster. And Kenneth, I think you were the one who asked, that's where your question comes in, right? Because you're like, Michael, I don't understand why we use the cluster IP and then we switch over to load balancers. And then someone was talking about using an ingress, and then someone mentioned external DNS and node ports.
Yeah.
All of those have to do with ingress to the cluster. But here's the thing that gets weird. I don't know why Kubernetes did this. Cluster IPs are only internal. I'm like, why do you call it a cluster IP if you're going to make it internal, right? Call it internal IP or something like that. Don't call it a cluster, because when you say the word cluster IP, I'm thinking that's something I can use from the outside world to get inside the cluster, because it's called the cluster IP. But nope, cluster IP might as well mean internal cluster IP address. So that's what, when they say cluster IP address and you switched over to it, you actually can't access that from outside the cluster. But let me talk about this for just a second. Every node inside of Kubernetes is assigned an IP address. So notice that this is a 74.100 right here, right? Notice that the pod was also assigned an IP address. That's a 1.194. You all following me? Notice there's two different IP addresses, one for the pod, one for the actual virtual machine. Okay, this is where it gets ugly. Remember I said networking and security were harder inside Kubernetes? So now, ignore all the words on the side. Please just ignore all the words. Ignore the destination and the target for a second. I've got pod A in the center. I've got pod B in the center. They are on the same physical host. They're not, this is not node to node. They are on the same physical node. And you know what happens? They just talk to each other. There's a virtual bridge. They talk to each other. They both have IP addresses. They both know how to find each other. We're good. But the traffic never leaves the host. Notice that elastic network interface down at the bottom? It never goes out the network interface. You know why? Because we're all in the same node. Nothing ever leaves, okay? Now, this is all intra-host, okay? So notice the traffic never leaves, never goes anywhere. It just all stays on the same physical node. But notice that the IP addresses for the actual pods are being advertised on the physical node. Like, be clear, the virtual node, but you understand what I'm saying. They're being advertised on the virtual machine. So if someone comes looking for the pod that has 1.95, they're going to hit that network card. This is no different than how it works with hypervisors. For those of you who deal with VMware and Zen, they also have to broadcast out the IP addresses for the virtual machines they're hosting. So for those of you dealing with networking, hopefully you're sticking with me. Now, what happens though if I have two virtual machines and I've got pods on two different virtual machines that want to talk to each other? This changes nothing. Just to make sure that this is consistent, if 194 wants to talk to 2.195, guess what happens? 1.194 comes out through the physical interface, goes and finds 2.195, and then it goes up and talks to the pod. Now, can you put firewalls in place to stop all this? Can you put pod security policies and other emission controllers and other things in place to stop any of this from happening, you 100% can. Absolutely. And most people do. By default, you can make it so nobody can talk to anybody, which is how most people do it, frankly. But just know that if you don't put any of those policies in place, by default, they can all talk to each other. Now, this is all inside the cluster. Same two nodes, they belong to the same Kubernetes cluster. A pod on one cluster can talk to a pod on one node, can talk to a pod on another node. No restrictions. Okay, that's great, Michael. Thank you for sharing that. So I now know how intra communication works, right? Perfect. What about if I want to come in from outside the cluster? Okay, this is where things get weird and ugly. So I'm just going to show you this diagram. I'm not going to show you the rest of this because networking, there are books written about Kubernetes networking all by itself. So let's leave it at that for a second. Here's how this works. The cluster IP is an internal IP address that is assigned to services inside the cluster. So for example, let's say that we decided that we wanted to have our own, Elasticsearch cluster to accept logs. We could assign it a cluster IP address, and every pod that was inside the cluster could hit this cluster IP address, and it would write it out to the Elasticsearch cluster. You could do that. That you would create a service. These are called Kubernetes services. Notice the services up here. You could create a service of a type called cluster IP address, and that cluster IP address would act as a load balancer, and it would send all its traffic over to this Elasticsearch instance over here. This only works internally. Remember all my whining earlier about how cluster IP should actually say internal IP. Because remember, this only works if you are inside the cluster. It will not work if you're outside the cluster. You cannot hit a cluster IP outside the cluster. The cluster will not accept traffic. But you're like, Michael, what if I am hosting my Elasticsearch logging on this Kubernetes cluster and I want to make sure all of my apps can hit it? Well, you've got two options. Well, you've got three options, actually. One, you can make a port available on every single host in the cluster, one port, same number, and that node port will actually redirect to a cluster IP, which then will redirect over to your Elasticsearch pods. If you're like a port on every IP address, if you're like, I don't like that, can I just have one IP address that I hit and it redirects out to everybody? Well, then you can create a service type called a load balancer. And if you're on a cloud provider like Azure, it will launch a cloud load balancer, which will then by default point to all of the nodes inside your cluster. They will refer to a cluster IP address, and then that will go out to your Elasticsearch cluster. Is anyone sick of the levels of abstraction yet? Do you guys all feel like you just found yourselves inside of a rabbit hole? You're like, hold on, load balancers use node ports, which uses cluster IPs, which then goes over to the pod? Yes, that's what happens. So, Kenneth, we're not going to spend too much longer on this, but all of this for the load balancer, all of this from the node port, those are all external IP addresses that are available outside of the cluster. Cluster IP addresses are not accessible outside of the cluster. And there's one more external type that's not a Kubernetes service. It's known as an ingress. An ingress is a layer 7 load balancer. So an ingress could be Azure's layer 7 load balancer. It could be AWS's. It could be Google's. Doesn't matter, right? But note that that's not a service. An ingress is a separate object inside Kubernetes. A service is any of these 4 objects. Okay. Does that answer your question, at least superficially?
Kind of, but we switched from load balancer to cluster IP, but they seem to be two different things based on your drawing there. So I don't understand why, like I would understand like a load balancer. My understanding was that we had like an Nginx load balancer, which would distribute the load to the instances or replicas inside of our cluster. I understand that if that's the way that worked, but I don't understand how cluster IP replaced that. It's still a mystery to me, but you don't have to spend more time on it. I'll do some research on my own.
Well, they probably could do that because the pods that were accessing the load balancer were probably already inside the cluster.
Okay.
So in other words, the cluster, whether it's a cluster IP, a node port, or a load balancer, they all act as load balancers.
Okay.
And I know that's confusing because you're like, but Michael, we installed Nginx to use as a load balancer on our system. You don't have to do that. Someone did that because they wanted the power that Nginx brought to the equation. You could have just used cluster IP addresses. But let me be clear. Cluster IP is an object inside Kubernetes. A load balancer, if you use Nginx, for example, or F5 or whatever you wanted to use for that, you would then get all the power that F5 and all the power that Nginx brings to that, including rule rewriting, all the stuff that you can do with a standard Nginx installation, right? You can't do that with cluster IP addresses.
So I think we do have an ingress.yaml file. And so do we still hit Nginx to distribute traffic within our cluster?
Yeah, so if you're using an ingress, remember that's another object. So think of
Right.
ingresses as sitting outside of this whole diagram right here. Ingresses, what ingresses usually do is what will happen is that ingresses will take traffic, they'll evaluate whatever rules the traffic is set to evaluate against, and then they in turn will send to a node port, which goes to a cluster IP, which goes over to the pod in question. So ingresses actually still use the same convention. They just sit outside of these objects.
All right. Thank you.
Yeah. Yeah. So Kubernetes, if nothing else, Kubernetes is all about wrapping abstractions around abstractions. So ingresses are a way for you to use your favorite software to do layer 7 routing and pathing. But if you don't do layer 7 routing and pathing, you're doing only layer 4. That's what a raw load balancer, a node port, and cluster IP address is for, is just for raw layer 4 network traffic. Meaning you're just doing like basically TCP IP routing. You're routing based on port number and IP address. If you need something more advanced, which is like HTTP web traffic routing based on suffixes like /mobile versus /desktop versus /Americas versus /APAC, you're going to need an ingress, which is what you just described, which is where you're basically reading the URL of the incoming traffic and you're routing based on what the URL says. That's layer 7 routing, which is what an ingress is used for. So that's the distinction. You have to use an ingress if you want to do layer 7 routing. If you're just doing layer 4 IP address, like socket basically pathing, you can use any of the things that are in blue on this page that you see. I know I just melted most of your brains and I apologize for that, but it's a worthy topic. Okay. Other questions about Kubernetes or anything else you might want to ask? I feel like that was pretty good for brain dead, Okay. All right, here's what I'd like to recommend then, because it's 2:05 and we've been going for an hour. We're gonna take a break. And the reason I'm recommending that we take a break now is that I'm gonna talk to you for about maybe another like 35, 45 minutes about Rancher. And then you're gonna spend the rest of the day in labs. So you're not gonna need a break at that point because you're gonna be working at your own pace. So, because just remember, this is, basically like a 3-hour class, right? So the goal here is to get you zoomed up on the basics of Kubernetes just to make sure you got the refresher. We're going to talk about Rancher, but quite frankly, I'm going to talk about a bunch of stuff that's probably going to be better for you to get your hands on it, because I can sit here and go through the command line and talk about it all day long. And you're going to be like, well, great, Michael's just going to go in one ear and out the other. And then we're going to spend at least the last hour or more working on labs. So if no one has any other questions. Let's take a break. All right, it's 2:06 right now. Let's come back in 14 minutes. So come back at 2:20. I'll put a timer up just so you can see, but 2:20. So it's 2:20 my time. It might be 1:20 yours. I'm not actually sure where you guys are located. But in 14 minutes, let's come back, okay? We'll see you in just a bit. That'll be under reactions for those of you who may not be aware. Okay. Okay. All right, as promised, we're going to talk about Rancher. Just a few quick logistics first. One, so same lab guide, same slide, lecture guide that you had before. Be aware that we are going to be doing lab 10. So yeah, keep it pretty simple this time around. So I'm going to talk about Rancher has an over and above add-on to Kubernetes, right? So just like, it's assumed, by the way, if you're running Kubernetes, you're going to be running some form of containerization. That's usually Docker. So you can't really run, let me rephrase that. You don't have to run a single Docker container to run Kubernetes. You could run them in another flavor. You could run them in Builder. You could run them in whatever. But just to say this, Rancher is only for Kubernetes clusters. And I will say something cool about Rancher is Rancher is really good about, even since they got bought by SUSE, Rancher is really good about giving back to the community. They're a good company. It's a bunch of really good folks with good intentions over there, at least, at least in the last 6 months, right? And you can get hooked to it with them in their Slack channels. It's a good crew, and they really are trying to make a piece of software that is affordable, and its sole function is just to help you manage multiple Kubernetes clusters. It really is just that simple. It has some complexity to it, but most of its complexity comes from Kubernetes. It doesn't come from Rancher. Let's talk about that. Okay, so what is Rancher? So Rancher used to be, sorry. Rancher is basically a container management platform for container orchestrators. Now, it used to be that Rancher had their own container orchestrator, and it was called Cattle. But that was so long ago, like 3 years ago. 1.6, I think, was the last one. I think they're on 2.6 now. So this thing called Cattle. So you're going to see Cattle referenced a lot inside of Rancher, like Cattle namespaces and Cattle system and because Cattle was the name of their orchestrator. About 3 or 4 years ago, Kubernetes demolished every other orchestrator out there in features and capability. And everybody, Docker gave up on their orchestrator, Rancher gave up on their orchestrator. Everybody just switched over to managing Kubernetes. Even Docker Swarm, which is now owned by a company called Mirantis, and it is in and of itself has its own orchestration tool. It supports Kubernetes as an orchestration tool. So a couple years back, Rancher was like, you know what? Let's just switch over to Kubernetes. Everybody's headed that way anyway. So, Rancher's job is to manage however many number of clusters that you have across local private or, hyperscale based cloud providers. They don't care. As long as it can talk to it and run the agent and it meets standard Kubernetes definitions. In other words, it is a certified CNCF Kubernetes distribution, Rancher will manage it. So what does it add then? Why would you do this? Well, I got to tell you, doing authentication for multiple Kubernetes clusters is a pain. So Rancher can simplify that. Monitoring, logging, and alerting is a pain. It's not impossible. It's just easier if you use something like Rancher. And then it has a bunch of additional things like Longhorn and Fleet and like storage subsystems and these kind of like CI/CD kind of like tools that you can use with Rancher, which we're really not going to talk about because they themselves are their own class. But it's just an enhancement layer for Kubernetes. It's just a management orchestration layer for Kubernetes. That's all it is. Now, it is completely open source, and the only difference between the open source version and the enterprise version is support. That's it. There are no features in the enterprise version that are not existent in the open source version. The difference is that, and this is like 2 years ago, so please don't quote me on cost here. For $150 a master, not a node, a master. I think it's per month or is it per year? Oh God, I don't even remember. I think it was per year, actually. You basically get enterprise support for those masters. That's pretty good. That's nothing, right? Rancher, by the way, has K3s. I can't remember what the name for that is. RKE, which is their Kubernetes distribution. Rancher Desktop, which I'm actually running. I'm testing it out. Rancher Desktop is like Docker Desktop. For those of you who've been using Docker Desktop, I don't know if you know, but if you use it inside your business, you have to pay a license for it. Some people want to do that. Some people are just moving over to Rancher Desktop, which has a lot of the same features. So Rancher is really good at giving back to community. Rancher is just like Kubernetes in that it basically launches a Kubernetes style setup on top of a bunch of Linux boxes, and then it encapsulates or eats Kubernetes clusters. Now, it can either spawn Kubernetes clusters or it can import Kubernetes clusters. But you can basically run Rancher on anything that will run a Docker container. So, yeah, here's an example of running it manually. Just to be clear, there's like 1,000 different ways to do this. I will tell you that I wish this was easier because this makes it seem like it's really simple, and probably it is. Like if you're running just like plain old Docker on your system, like if you have a Mac, which hopefully most of you do, or you're running a Linux box, which hopefully some of you are. In Windows, this doesn't necessarily work as easy as you want it to. I work on all 3 operating systems, so I try to stay abreast with Windows, but sometimes Windows does not do this very well, especially when you try to run kube commands like bash. If you're running it in get bash, they won't work as well. So just to be prepared for some headaches if you're running it on Windows. The reason, by the way, just to mention this, is that the Kubernetes team has no intention of ever converting the masters over to Windows. So they'll let you run Windows nodes and Linux nodes, but they won't let you run Windows masters. You can only run Linux masters. That's their current roadmap. Maybe they'll change that in the future. I think there's just too much required kernel change wise for them to get that to function. Now, Microsoft has its own containerization system, which is not the same as Kubernetes. So, test your theories there before you assume that it works the identical. Okay. So, oh wow, that's what happens when you hit the home button instead of the page up button. Let's switch that down. Oh man. Okay, there we go. That's what I'm looking for. All right. All right, so let's talk about the Rancher architecture. Now, here's the cool thing. This architecture is going to look almost identical to the architecture you saw for Kubernetes. Here's some distinctions that are a little different. Here's the API server. That's cool. We love that because we want the API server. Here's etcd. Someone's got to store state. Notice this is Rancher. This is not Kubernetes. This is Rancher. Almost exactly like Kubernetes, though, isn't it? Now, instead of a cloud controller, by the way, or a controller manager, it's going to have a cluster controller and another cluster controller. And there's going to be a cluster controller for every single cluster it is in charge of. So if you have 1,000 clusters under Rancher's control, this single installation of Rancher's control, there's going to be 1,000 cluster controllers. Notice there's also an authentication proxy, right? So authentication proxy, I don't think that was missing from earlier, but this is where the Rancher UI or the Kubernetes kubectl or the kube API is going to authenticate against Rancher in order to get down to these clusters. What happens is that when you hit Rancher, it authenticates and then basically passes like authentication like a token. Basically, it uses a service account, just to be upfront about it. It uses a service account to talk and manage on your behalf these clusters when you make calls in through Rancher. Can you get directly to these systems? You can. They call them cluster endpoints. You can actually make cluster endpoints, which we'll talk about in a second. If you have a server in Asia and your Rancher installation is in North America, and you have users in India who need to manage that system, but you don't want them to go all the way back to North America, you can actually create a cluster endpoint and have them manage the cluster directly. They still have to authenticate, but the endpoint's right there. So do note that there's no scheduler here because it's not doing any scheduling because the scheduler is going to live down here, right, on the cluster. Notice also that it doesn't have any cloud controller because it's not creating any objects. It's just managing Kubernetes clusters, right? So the cloud controller is going to be down here. There's no controller manager because it doesn't need that because the controller manager is going to live down here in each of the clusters, right? So some of the components don't live in Rancher because they don't need to. But you see etcd and you see the API server and you see there's some controllers there. Obviously, the authentication proxy is new. Note that every cluster is going to end up with a cluster agent. They're also going to end up with a secondary kind of backup agent, which usually lives down in the kubelet area. So you're going to end up with a cluster agent. And there's like a secondary agent. I don't remember what that's called. I want to say it's called a node agent. It's like a backup agent. And what it does is if for some reason this guy goes down, the cluster controller will talk directly with this node agent that's down here. It runs as a daemon set on every single node inside the subclusters for Rancher. So be aware that you are actually going to authenticate into Rancher usually to get to your clusters. That's how it usually works when Rancher's at play. Any questions about the basic design of this from a Rancher perspective before we go forward? Are you all riveted? Is your life now complete that you now have seen the internals of Rancher? No, that's too bad. I was trying. All right. Note, by the way, that I think, oh, sorry, Robert, were you going to say something?
Yeah, just one, is it very similar to like OpenShift?
Oh God, no.
Oh,
Oh no. I worked on OpenShift actually for Red Hat back in 2020. And have done some really big installations of OpenShift. OpenShift is a collection of 300 open source projects that Red Hat stacked together, of which Kubernetes is one of them, right?
yeah.
So OpenShift is a huge product. Now it's a great product. I like it, especially for people who are new to Kubernetes. I think OpenShift is better for new teams to start out with. But OpenShift has so many more capabilities than Rancher does, but it also solves a lot of problems that people have already solved. Like, for example, you all probably already have CI/CD pipelines inside your systems, right?
Mhm.
Well, OpenShift comes with that, and most of you don't need it, right? It
Yeah.
also comes with like, this templating engines and all kinds of stuff that you probably don't need. But that being said, OpenShift is pretty cool. It's kind of cumbersome. So OpenShift is a much bigger product. To say this though, the base components work exactly the same. OpenShift has the concept of masters. It also eats, obviously the Kubernetes cluster itself. So in that way, it's very similar to how Rancher does it. The difference is that OpenShift is way bigger than Rancher in terms of capabilities.
Yep, makes sense.
And I will point out though that the price tag is steeper as well. So
Right.
I can't give you any numbers, but the last time I looked at it, when I bought it in 2019 for Honeywell, it was like $2,400 per processor pair. Oh, sorry, for core pair.
Yep.
Yeah, so it was a lot, but worth it for year one, just to say this. But I would do a thorough evaluation because Rancher is a lot lighter and easier to use and solves a smaller set of problems. OpenShift will solve a much larger set of problems with a much larger price tag. Both will provide you enterprise class support. Just to say this, now that Rancher is part of SUSE, I think support's even better, but Red Hat's been doing it for a while, so they're pretty good company to deal with. So it just depends on what you're looking for.
Yeah, so Rancher is really just the core management features, whereas OpenShift has got that plus a whole bunch of other functionality and packages built into it.
Oh yeah, so much more. Matter of fact, if you were like, hey, we want to start over and just create a whole CI/CD pipeline from scratch that will read from repo, and from commit to deploy, we want to just have that whole thing figured out. OpenShift is going to be your friend. If you're like, well, we already got most of that figured out, we just want to insert Kubernetes on the end, Rancher's really going to be more appropriate. So,
Thank you.
yeah, I could go on and on. OpenShift has built-in monitor. Anyway, there's a lot. So, so probably just a quick rehash is that the authentication proxy, right? All the calls are going to go through the authentication proxy. It's going to forward those calls with the service account token to the respective downstream clusters. So you hit Rancher first, Rancher forwards it. You don't have to do anything. It just does it for you. Just letting you know what goes on. It does. Oh, it says it right here. Uses a service account to communicate to K8s clusters. We are talking about version 2.6. I don't think that 2.7 or 2.8 are out, but I haven't looked in a minute, so I could be off on that. API server works just like it does in Kubernetes. Central hub for all communications. Nobody talks to really anybody directly. The authentication proxy is the only like first entry point. This is very different than Kubernetes, in which you usually talk to the API server directly. So notice that from here, the API server is going to talk to the API servers that are downstream on each of the Kubernetes clusters. So from here, it actually goes to the cluster controller and talks to the API servers downstream. Each cluster controller has a cluster agent on each downstream Kubernetes cluster. And remember, there is that node agent. I think I'm saying that right. Pulling that from memory. There's like a backup node agent that runs on each of the Kubernetes clusters as well. You can, by the way, set access control policies to both an entire cluster, to namespaces, and to what they call projects. Projects are collections of Kubernetes namespaces. So projects are an OpenShift and a Rancher construct. So both OpenShift and Rancher has this concept of projects. So like if David, Dennis, and Ryan were part of the same team, and they both are supposed to all have access to the same projects, but they got 5 projects they have to manage, they would be in a project for their respective team, and all of their namespaces for their 5 projects would all be part of that project. Now, if Kenneth, Jonathan, and Terrence had another different set of 5 applications they were working on, those 5 applications would be in their own namespaces, and Kenneth, Jonathan, and Terrence would actually be part of a project that had those 5 namespaces part of it. So projects are a way for you to organize namespaces to create your another layer of security isolation between all the namespaces. So think of projects as a way of you grouping namespaces together and giving users or groups access to those collections of namespaces. You can say, well, Michael, why wouldn't you just stick it all in one namespace? Well, security is not going to like that, first of all, because just to be clear, everything should be partitioned. Because unless the application is all part of the same product group, that's not going to meet standards on almost any company I'm aware of. So you're going to need these security partitions in order to just meet base compliance, not even just advanced compliances. So just know projects are collections of namespaces. Namespaces allow you to segment of a cluster into these virtual partitions. So you got the cluster controllers to enforce that as well. Now, I mentioned before these little agents that run on the cluster. Where are these agents? Here they are. The little cluster agents. Notice the big red arrow right there. That agent is the one that talks to the cluster controller, uses that service account in order to authenticate against the API server inside the control plane. Whatever that control plane is. It could be AKS, GKE, EKS. It could be on your VMware servers. It doesn't matter. It is node agent. I did remember that correctly. In the event that the cluster agent goes down, the node agent, which is on the nodes, will actually create a tunnel back to the cluster controller. So Rancher never loses communication, even if that pod fails or restarts. So just know that Rancher does try to design this with some concurrency, some redundancy in mind in case the primary method of communication and management fails. So there's the node agent. Now notice, this is like a whole now big old picture now, right? We've gotten a lot bigger. Sound like somebody had a question.
It says one of the node agents. How many node agents can live?
There will be a node agent for every node inside the Kubernetes cluster.
Okay.
So in the event, for example, if this cluster agent right here goes down for the entire cluster, each of these node agents will open their own tunnel back to the cluster controller. In other words, they will independently report back to the cluster controller in the event of that cluster agent goes down. That's pretty good redundancy, actually, from my perspective. I don't know of a better way they could have tackled that.
So let me ask a question, Michael. The node agent is specific to Rancher, but the kubelet is specific to Kubernetes. That's the distinction?
That's exactly right. Yeah.
Thank you.
Every single node inside of a Kubernetes cluster has to run a kubelet. The kubelet typically on the worker nodes handles all the things like, you know, scheduling and communication, like communication back to the API server. There's also another piece of software that Kubernetes puts on here called a kube proxy, and that handles all the networking. So those two pieces of software, the kubelet and the kube proxy, are native to Kubernetes. The node agent is 100% a Rancher construct. Let's see. Notice here, by the way, in this particular case, this user is actually talking directly to the API server in Kubernetes. This is a what Rancher calls an endpoint, like a local endpoint. It basically allows a user to talk directly to the API server if it's authenticated. So this is not for unauthenticated access. You have to still have authentication. All the policies still apply. But notice that this user is not going up here to the authentication proxy. They're just talking directly to the API server. Notice that the API server will talk to this kube auth, right, to make sure that it has authentication. And if necessary, it will go back to the authentication proxy if it doesn't have a like fresh copy of the security context for this user. So do note there's a little bit of caching that happens, but not a lot. So that's only if like the user's like repeatedly running commands and it's been in a certain recency. You can obviously set the expiration or the time to live for that caching. And if you don't want it to do any caching, you can do that as well. Just make sure that this connection between these two, or between the node agents and make sure that all those are good. Networking for distributed systems becomes incredibly, like a lot more important, because the minute these systems fail or blip, it's going to cause disconnects. They'll recover very gracefully, but if there's consistent network degradation, you're going to have a hard time with your Kubernetes clusters. I've been in environments where people were like, man, our networking is rock solid. You know, we have a minimum set of drop packets or whatever. And, you know, connectivity would blip and there would be all this failover and all this other stuff. And the Kubernetes cluster just did not handle that super well. The minute we put them into a more stable environment, Kubernetes ran great. So just know that whatever issues you had prior to running Kubernetes is not going to deal with those very well if you already have existing networking issues. Hopefully that's not true in 2022, but I know we all have our own business constraints. So notice here, we've got a controller, cluster controller 1, a 2, and a 3. Notice that there are other Kubernetes clusters up here that Alice could talk to directly if there is a cluster endpoint available for her to talk to. So just keep that in mind. All right. And this is the authorized cluster endpoints. That's what I was talking about, where you can actually bypass the like Rancher authentication proxy. That way you don't have to go all the way back to Rancher. You can actually just go back to the system. You might, by the way, increase caching on this system if it's geographically dispersed. Obviously, you need to make sure you understand the security implications of doing that kind of thing. But so here, notice there's some big red arrows showing how it's just doing local authentication. That local will, by the way, go back to the authentication proxy if necessary, based on whatever TTL you set. So again, I think I covered all that already. Okay. So this is what you need to know. Open source management platform for managing Kubernetes uses a very similar architecture to Kubernetes. It uses etcd and API servers and whatnot. It can manage one installation of Rancher can manage thousands of Kubernetes installations, right? It can launch them, it can import them, right? You can do all kinds of things. And by the way, these can be edge installations. These could be like huge hyperscale cluster installations. This size does not matter to Rancher because Rancher is not managing the cluster details. It's managing the cluster as a whole, right? It's not managing the actual details of the cluster. SUSE picked them up in 2020, late 2020. There are tons of other projects that Rancher contributes to. Great product, very slim, very light, good to get started with. Great to have enterprise support for year one. I could probably argue that I think OpenShift would be better for teams that are not familiar with Kubernetes yet, but this is a great second option if you want someone to provide support to you. Rancher is a good company, so. And let's talk a little bit about workload management, but does anyone have any questions about Rancher, any other curiosities, anything they wanted to ask about the landscape?
So is the etcd used for both at the Kubernetes level and at the Rancher level?
They both have their own separate etcd databases.
Okay, and they're both utilized.
Yes.
Okay, Thank
Some
you.
people will actually in their Kubernetes cluster, not their Rancher cluster, the Kubernetes cluster, they'll externalize etcd outside of the cluster. I've seen some people run their Rancher installations on the same cluster as their externalized etcd cluster. That is not recommended. Typically keep them separate. Because if that etcd database corrupts, you won't be able to make any changes to Kubernetes or to Rancher. So be careful with that. Keep it all independent, just like a microservices architecture. I know it adds more overhead, but more independence, more security context, more isolation. It's better that way. Terrence, was that a lung? Are we both coughing?
yes.
I'm sorry to hear that, man. All right, other questions? Okay. Let me just check this really quick. Oh yeah, yeah. All right. So this is the one that for the most part, I'm gonna talk about at a high level. It's only a few slides. We only got like 15 more slides to go, and then I'm gonna put you in the labs as quickly as possible. Mainly because a lot of the stuff I'm gonna talk about is just a repeat of stuff that you've already seen in Kubernetes, and I really kind of want you to stand up the Rancher installation and be able to explore the interface. That's probably the best way to get started with this. So first of all, here's the Rancher interface. I think I actually have mine up and running. I was having some trouble with it earlier, but I think it's up and running. Hey, look, there's an API key. You can copy all my security stuff. So like here, this is a big old interface. Notice that this follows like standard convention. Like this is the Rancher management interface. Notice that like up here is like, I'm logged in as admin and here's my API keys. And if I want to set any preferences or whatnot, all the community support and commercial support are all over here. I can actually create a cluster, especially if I have any keys imported into my system. Like if I have, K8s, Azure set up and Google set up. I can also kick it onto virtual machines. So I don't have to kick it on. I don't have to spin up a managed Kubernetes service. I can actually just spin up some virtual machines and have it done that way. I can also do a lot of custom stuff. Now it's going to ask you what you want, and it's going to ask you for some credentials. So for example, if I said, hey, I want to do K8s, it's going to ask you to basically set up your credentials, right? That you're going to use for the cluster, some details, any IDs, any secrets, that kind of thing. And then it's going to ask you what drivers you want. There's certain security policies you want to use, or certain types of networking drivers that you want to like put in place. It's going to ask you all those questions. And then there's a couple of advanced things that you can set up, but for the most part, it's going to ask you some basic questions, and then you're going to like let it kick up a cluster. A lot of people provision the clusters like using Terraform or my brain just failed me. Azure resource templates. I can't remember the name now, but they'll use some kind of infrastructure as code, and then they'll import it into Rancher. I don't see a lot of people using a Rancher to kick off clusters, because usually there's a lot of like customizations that have to happen, and so they'll solve that using some kind of either Pulumi or Terraform or some other kind of infrastructure as code setup. So you can do things like that. Now, if I've already got a cluster into the system, I can click into the cluster and notice that it now says that I'm local. And look how it says only user namespaces. So I'm going to click that off because I want all namespaces. And notice here that, it's got the provider versions and how long it's been created for, the number of nodes, only got one, and just like a quick listing of all events. There are free ports for the requested pod efforts. Really? Take a look at that. But here, by the way, are all the workload types. So these workload types look familiar. Guess what? It's going to be exactly like Kubernetes workload types, right? 28 total pods. I've got 3 daemon sets. Notice I've got Bitnami and WordPress and traffic. I've got a bunch of deployment type workload types. Notice I've got Fleet out here, which is it's kind of a CI/CD tool for Rancher. Got some cert managers, which is required for work. Oh, Jade Shooter, that's right. My son asked me to co-write a top-down, almost like Galaga shooter with him in Python, and so we found one. He wants to put all this music on there. I'm like, man, we don't have enough copyright money in the world to do what you're suggesting. He wants to put all this famous music on top of his shooter. Anyway, DNS, storage, traffic, by the way, is like a load balancer, probably the best way to say it. Probably a little bit more like a service mesh. Notice there's a stateful set here, right? What's running in a stateful set? I got a database. I'm running the MariaDB, right? Or Maria, however you want to say it. MariaDB, which is just a MySQL clone, right? And then notice I have a couple of jobs here, a couple of batch jobs. I'm not sure exactly what I was doing with that. I think those are just installation jobs, actually, to set up Rancher. Galaga. Yeah, good stuff. Notice, by the way, there's other things in here like charts, so I can install I can install a bunch of stuff. I can install a service mesh. I can install Prometheus with logging just with a click. Like a click gets this whole thing installed. So, and notice there's JFrogs out here. There's Datadog. I mean, it's it's a lot. This is one of the great things about Rancher also is that Rancher will provide you access to these kind of things. And there's a lot more that you can add than just these are just the defaults. I have not added any other repositories in here. These are just the ones that come with it. Notice there's a number of installed apps. I've got 3 repositories added in, just the basics. You can do things like manage DNS and service discovery. So if you want to set up some network policies to control firewall access and whatnot, notice that the default is to allow all. I don't have a deny all yet because this is not, it's not a production cluster. It's just a demo cluster. Here's all the services in reference to an earlier question. Services are how you basically either create a cluster IP for internal load balancing or you create all the other objects for external load balancing. Notice that the type is listed over here. So here's all the cluster IP addresses. Oh, look at that. Here's a load balancer. I don't have any ingresses. I have no node ports, no external DNS. But notice that in order to even get to Rancher, it actually runs through traffic, which is my load balancer type down here. So that's how you set up basically load balancers. And then here's things like storage. So I can set up persistent volumes, which someone mentioned earlier. Persistent volumes are how you make pods retain information. Notice that WordPress, it better have a persistent volume. You think I want to recreate that database every single time? No. So if you don't want to recreate the information, if your pod is not stateless, you need to have a persistent volume underneath it. Notice it's just oh, hey, you know what? Do you want to download the YAML that you used to create this? Kind of nice, huh? Here's the storage classes. Notice I only have local storage. I'm not using Rook or Ceph or NFS or anything else. And then config maps and secrets are just ways for you to configure sensitive and non-sensitive information. So config maps are non-sensitive, secrets are sensitive. So like if I want to store like database passwords, I'm going to put them in secrets. So glad you couldn't hear that. If there's any like bootstrap data or anything like that, it's sensitive. It just goes into what's called a secret. I want to just forewarn you though, for security people, by default, Kubernetes does not encrypt secrets. They are base 64 encoded. So please make sure that you're either using an external vault, like Vault, or something else that actually encrypts your secrets, or turn on encryption inside of etcd. But for those of you security people, please be aware that secrets are not encrypted. They're just base 64 encoded. So no one can look over your shoulder and just memorize it, but it's still base 64. You can decode base 64 easily. It's a command, single command. And remember, config master just for configuration information. These are all, by the way, Kubernetes objects. None of the things we've talked about thus far are local to Rancher, except for the app marketplace. That app marketplace is all Helm, which you did a lab on Helm last week. These are just Helm charts for the most part that have been set up. Everything else, RBAC, batch, cert man, all the other stuff. But some of these are add-ons. Like when I installed Cert Manager, it added in a Cert Manager plugin, right? When I added on Fleet, it added on a bunch of Fleet stuff. So this is another thing about Rancher, is that when you add in charts and stuff like that that extend functionality, this is true for Kubernetes, but very true for Rancher as well. It's going to show up in the web interface. So be mindful that you could have a lot of stuff hidden under more resources if you keep adding and extending Rancher. Okay. That's the dashboard. Workloads, marketplace, service discovery, storage, access control, basically. And then anything else is a catch-all that falls under more resources. Again, reminder that I'm under the local cluster. There are other things that are global, like user authentication and global settings. So for example, if we look under users and authentication, notice that I have the default admin whose local username is admin, right? Obviously, remember looking for these 3 dots, you can view the YAML, edit the config if you want to. So if I want to generate a new password, or I want to do restrictions on the administrator, there's a couple options here. Notice here that since I'm under users and authentications, here are all the roles. Here's groups, which is just collections of users. Notice I don't have any groups. And notice that because I'm using local authorization, because I'm authenticating with Rancher locally and I'm not federating with somebody else, there's no group setups here. If I was with Active Directory or Okta or Ping Federated or whatever, there would be groups here. So I could link groups in Okta with groups over here. Okay. And this is where you would set up your auth providers. So here are your options. So particularly for those of you who are operators or security minded folks, there you go. And I just want to say that you can basically, as long as it supports OAuth 2.0, you're good. Like you can actually configure it to talk to any system that supports OAuth and OIDC. And then there are a couple of global settings, like, you need URLs for whatever. I'm not really going to go over that because that's like deep into the meta. Notice the like if you're doing continuous delivery, like if you're like looking at Git repos, like you want to pull in, this starts to get into features that are similar to what OpenShift has, but not as advanced. You can also do advanced cluster management, like set policies like across an entire, like all your clusters if you want to. And then there is some virtualization management. I gotta tell you, I haven't used Harvester a whole lot. It's basically, hold on 1 second. It's basically for hyper-converged infrastructure. So like Rancher's trying to make sure that it's as easy as possible to launch these things inside your data center. So they support a lot of bare metal kind of like hyper-converged infrastructure like Nutanix and stuff like that. So So that's all the extra stuff that's outside of the cluster management, right? And so notice that this stuff is not really, it's not like, it's Rancher specific. It's not Kubernetes specific per se. Once you get inside of a cluster, that's when you start getting into really Kubernetes specific items. All right. That, everything we just went through is basically just us going through the entire interface, right? Notice that there were more options in my interface than were listed here because this, is updated all the time. Notice that there is a Rancher command line tool. You will have to get a bearer token in order to use it, and you will have to resolve your URL. Where do you get a bearer token? Well, basically, you just click on your profile in the upper right-hand side, click on API and account keys, right? You can create an API key. You can put whatever scope and descriptions you want on there if you want. We definitely set an expiration. Let's say a day from now. Create, and then here's your bearer token, right? Copy that. And then what happens is that when you get to Git, you would literally just type that command as it's listed there, actually. And I remember I was trying to mess with this earlier, and for some reason I was having issues. Not sure why, but notice here that I'm running Rancher login, rancher.local token. And I think the reason is I put traffic. I put traffic as a load balancer in front of my Rancher installation, and traffic is returning a different SSL certificate than rancher.local. So I'm having my own personal issues over here. It has nothing to do with y'all. But this is how the command works. Rancher, I wouldn't do that // That's going to throw a lot of things off. Just do Rancher. If Rancher's not in your path, you should make sure it's in your path. Just do Rancher login and then the server and then -- token and bearer token. Notice that Rancher can be put in front of any Kubernetes command to get the command to run against any Kubernetes cluster. So you can run kubes like your kubectl commands, you just to put Rancher in front of it. I gotta tell you, I'm a big fan of alias. If you do this kind of thing, that's fine. I usually alias, by the way, K equal to kubectl. So that way I can just do K get pods -a. For those of you who are not familiar with the command line, probably want to do that. And I usually just alias R equal to Rancher. Right? So that way you can do I don't think this is going to work. It's going to tell me to log in, but regardless. Oh, that's right, because it's not going to like that. It's not going to do substitution. So notice there R was submitted and it basically said run login because it wants me to do Rancher login. Right. So just be careful. You can run all of your kubectl commands prefaced with Rancher, and you can actually specify the cluster you want. You will have to change context or project. So in Rancher, it's going to ask you to set the context of which cluster you're talking to. And then when you run the kubectl command, it's going to run it against that cluster. So just like kube, you have to be set against the context that you want. Okay. So the Rancher CLI works almost exactly like the kube CLI. You probably will end up using both. The one thing that's probably super important is this. Projects. Remember how I mentioned before, projects are collections of namespaces. People will wreck themselves. They'll get super frustrated because they're like, how come I can't see the application I just deployed? If you cannot see the application that you just deployed, it's because you're either in the wrong namespace or you're in the wrong project or both. Okay. So just remember I said that because people are like, well, hold on, Michael. I was just out here and I just, where's Rancher? I know Rancher is out here. I deployed it, but it's not showing up right here. Where is it? I don't see Rancher. And here's the problem. If you do not specify a namespace, it's going to go to the default namespace. If all of a sudden I specify namespace, guess what happens? I see what I'm expecting to see. So be clear that the command line is already kind of like cryptic enough. Just know that with Kubernetes and with Rancher, you have to specify which window in the cluster you want to look through. And that's what the namespaces are. They're little windows. They're little like security partitions. So just be aware that you have to do that kind of thing. I know it's horrible. And we already talked about workloads. So you're familiar with that. We talked about namespaces. We talked about projects already. So that's all familiar. We already talked about how projects can support security policies and pipelines and et cetera, et cetera, et cetera. We already talked about how Rancher needs you to be set on the project that you need to focus on if you're going to run the Rancher command line. Rancher context switch, the list of projects, yeah. Okay. We already saw that where I clicked out of it inside the UI. Let's see. All of your Kubernetes commands work for scaling. So if you want to edit the file, you can. If you want to run kubectl scale, you can do that. Again, we're kind of getting into things that you've already seen because you did this when you did your Kubernetes labs last week. Storage doesn't change. Storage works exactly the same in Rancher. Sorry, I'm not trying to skip through this, but you've already seen most of this. So I don't think there's anything new here. If you have any questions about anything, please ask me. Adding the volumes there. Okay. Networking, we've already talked about. Oh, they do have the concept of headless. If you want to start a service object and you don't want it to do any routing or whatever, I don't know why, but Rancher supports that as a service. That's just you launching a pod with no services, basically. So I'm not sure exactly why that's listed there. Most of the time, by the way, we use cluster IPs or we use load balancers to do our stuff. We try to avoid node ports and we try to avoid headless as an option. We already talked about all that. Okay. So bottom line, one, you've got this pretty awesome web interface for Rancher. It allows you to like do a bunch of things, including get inside a cluster, including like, manage a bunch of things globally, including configuration. Upper right-hand side allows you to do things like API keys and whatnot. There is, by the way, if you want to open a shell directly into your cluster, you can open things like kubectl and it'll open it up for you. Eventually, it'll take a second for it to connect. Notice here that I'm actually, it's like think of this as like a cloud shell, right? Exact same thing that I was running on the command line. I got to tell you personally, I prefer the command line because I have more control over characteristics. But if you are connecting to a remote cluster and you don't want to go through the whole local access thing, just know that this is here. You can upload files. You can download config files. Like if you want to download your configuration to get access to the cluster, you can copy it to a clipboard. You can extend that as well. So if you have your favorite cluster that you always log into, you can set that as your login page. So once you log in, it goes right into the cluster. So just know this is here. Remember, Rancher is the management layer. It eats Kubernetes clusters and makes them its own. It has its own kind of cluster controller plus node agents that kind of like sit in relationship with Kubernetes clusters. Remember that projects are something that that Rancher introduced that is just collections of namespaces. That was something, by the way, that both Rancher and OpenShift did in collaboration. So Red Hat did that with them. Okay. Questions in general about Rancher before you install Rancher in your lab environment? Okay. Let me just mention this last little piece. So logging, by the way, works very different inside the new versions of Rancher. So just know that logging, like Kubernetes by default logs almost everything in the cluster and everything that happens at a pod level. Where do those logs get saved? Well, just so you know, Rancher makes this easier by allowing you to automatically have those logs captured and then shot off to whatever data store you want. So for example, you can see it down at the bottom. If you want to get to go to Elasticsearch, it can. If you want to go to some other service, right, whatever, other, like Loggly or whatever, you can do that as well. So just know that when that app store that we were looking at before, if I come over here and I'm like, hey, you know, I really would like to look for, you know, something that I can install over here, there's a logging operator. So if I click on this and I turn and I install this in the upper right-hand side, this will allow me to collect a bunch of namespace and cluster logs along with the pod logs and actually put them out into a default provider like Elasticsearch or Loggly or Splunk or somebody else. Okay. So that's the main thing this diagram tells you, is that Rancher enables that kind of thing to happen a lot easier. In addition, you can also in that same spot turn on Prometheus, which is a monitoring system for Kubernetes. Prometheus is built to monitor Kubernetes, and we'll also add in Grafana, which is a dashboard, an alert manager, which is an alert manager, and it will make sure all that is set up and working for you. So Rancher will do that a lot easier for you as well. So just know you can also, with a click, just enable monitoring. You can also enable what they call service mesh. You can enable logging, monitoring, service mesh. You can enable a bunch of things out of the box with Rancher. Not going to go over this because this is way above and beyond the scope of the Prometheus architecture. That could be a whole class in and of itself. Just know it's here if you want to look at it. Probably would read the Prometheus documentation, honestly. Here's an important thing though. You probably had a section on Kubernetes troubleshooting. Every single thing that you did for troubleshooting in Kubernetes, it all applies to Rancher. You are going to run the same commands. You're going to run get pods with an O wide. You're going to describe the pods. You're going to look at the logs for the cluster, and you're going to get the events. These are the 4 core commands that everybody runs to troubleshoot what's going on inside of Kubernetes. I want to share this little gem I found the other day. Oh God, did I save that URL? Hold on. Hold on. Oh, hold on. It was a troubleshooting flowchart. Where are you? Are you there? Oh, here it is. Yeah, I found it. Hey, I'm going to share this with y'all. This is a fun little flowchart. If you ever need to figure out like what to do to troubleshoot something, you can start up in this upper left-hand side and just follow what it says. If you ever are having to troubleshoot why something is going in a certain direction, this little flowchart is a great little thing to have. It'll take you through everything from troubleshooting pods to troubleshooting ingresses, services, and it'll give you suggestions as to what to look at to fix the problem. In other words, did you define the image with the wrong tag? Did you somehow define a load balancer of the wrong type? It'll help you figure those things out. So I just posted that in the chat, but you want to put that in your back pocket. This little, this is from the Learn K8s website. Fun little flow chart to help you troubleshoot problems. Bottom line is that whenever you do any troubleshooting, the idea is data. Try to get as much information about what you're looking at and try to find out what the error is. And once you get the error, see if you can find if it's linked to any other errors to find out what the issue is. Eventually you'll find something, some smoking gun that will help you figure it out. If in doubt, that's why you got Rancher on support, right? That's why you got OpenShift on support, is you can call them up. If in doubt, by the way, also know that Slack, that would be a bold move. Slack does actually have a Kubernetes users channel as an example. There's also a SUSE channel. Sorry, a Rancher channel. So Rancher users, right? So just know that you want to, if you are in the position of supporting a cluster, or even if you just have questions, feel free to come out here and take a look at these, because this place is typically pretty busy. So, and they will answer your questions. They will do your best, especially if it's well worded and very clear about what you're asking about. If you put in detail, including version numbers and whatnot, they will help you. It's a great community in that way. Okay. The purpose of that whole last section was just to tell you that Rancher can enable monitoring, logging, and service mesh for you. Troubleshooting is fairly the same thing that you would do with Kubernetes. It's about getting events, getting logs, and describing the objects in question. Knowing the architecture does help with troubleshooting. If in doubt, go talk to the community, go talk to your support reps. You lose that flow chart that I gave you. See if that will help you figure things out. Questions of any type? Okay. Ask away at any time. Here's what we're going to do now. Is that hopefully you have an email that looks something like this. Oh God, what did I do with that? Here we go. This was an email I think all of you got that should have had, like, your machines and your logins for Azure and all that stuff. You're not going to leave your logins for Azure, but this should give you access to your virtual machines. The username and password, by the way, is right down at the bottom. What we're going to do now is we're going to finish out the class by just doing this last lab, which is you basically installing Rancher. You are going to work with the 3098 machine. So if we go back to this, you're going to use the one on the top. This is the 3098 machine. So Krista will use the one that says 107 at the very end, and it says 3098 in the top. That's what she's going to use. So all of you, make sure you log into your 3098 machines. And then you're going to follow the steps step by step. You're basically going to install Rancher into your local Kubernetes cluster, which is, is going to be interesting. So hopefully you all are still logged into Docker from your previous incarnation. So these should be the same virtual machines that you had up before. So you should all still have logins to Docker. Okay. That's it. Now here's how this will work. This is the last 45 minutes of class. I have no closing notes for you other than thank you for being in the class. I'm going to post an evaluation that ideally you should do before you leave. Do note that Kroger is pretty strict about that, so please fill it out before you go. And then we're done. So the minute you're done with the lab and you're done with the evaluation, I'm done with you. You can ask me any questions you want, but otherwise you can leave early if you get done early, or I'll be hanging out with you until 4 o'clock, okay?
Is there a link to the evaluation?
I'm going to post it in the chat here in just a second. Good. Other questions?
Will the recordings be links report be posted as well?
Yes, and actually, since we're starting the lab, I'm actually going to stop recording. And what I'll do is I'm actually